Imagine a hidden world within your body, where tiny molecules called bile salts wield the power to unravel the mysteries of fat digestion. From the depths of your gallbladder to the intricate pathways of your small intestine, their silent but mighty orchestration transforms the daunting task of breaking down greasy meals into a seamless dance of molecular precision. Your journey starts in the gallbladder. Make sure to watch till the end of the video, because you won't want to miss how your gallbladder achieves fat absorption and all that's in between. So let's start at the very beginning. Let's imagine eating a greasy burger. When your burger finally reaches the small intestine, the duodenum to be specific, the greasy fat molecules are too big to be absorbed as they are. So this is the part where your gallbladder steps in as a superhero. Emulsification process. Here, bile salts and bile act like detergents, surrounding fat molecules and breaking them down into smaller droplets through a process called emulsification. This process increases the surface area of fat, making it more accessible to digestive enzymes. Without emulsification, fat digestion would be much less efficient because digestive enzymes would have a harder time accessing the large fat molecules. Next, enhanced enzymatic action. Once the fat is emulsified, pancreatic lipase, along with other enzymes, can efficiently break down the smaller fat droplets into even smaller components. Pancreatic lipase specifically targets the bonds within triglycerides, the main form of dietary fat, to release free fatty acids and monoglycerides, which are easier for the body to absorb. Micelle formation and absorption. The products of fat digestion, including free fatty acids, monoglycerides, cholesterol and fat-soluble vitamins A, D, E, and K, along with bile salts, form structures called micelles. Micelles are tiny, water-soluble spheres with hydrophobic, water-repelling interiors and hydrophilic, water-attracting exteriors. This structure allows them to transport fat breakdown products through the watery environment of the small intestine to the surface of the intestinal cells, known as enterocytes. Facilitated absorption. Once the micelles, as mentioned, reach the surface of the enterocytes, the fatty acids, monoglycerides, and fat-soluble vitamins are absorbed into the cells. Inside the cells, these molecules are reassembled into triglycerides, which are then packaged into structures called chylomicrons. Chylomicrons are essentially large lipoprotein particles that transport dietary fats and fat-soluble vitamins from the intestine to the lymphatic system and eventually to the bloodstream. They act as cargo vessels getting their merchandise to their final destination. Fascinating, right? But it doesn't end here. Chylomicrons travel through the lymphatic system and eventually enter the bloodstream, where they deliver their cargo of fats and fat-soluble vitamins to various tissues in the body. These nutrients are either used for energy by cells or stored for later use in adipose tissue.